And I now invite Manish, which, by the way, it's an honor having you here. A part of everything that he is, he just won the Sidney Furbeck Award of the IEEE Computer Science 2023. And that was on a morning, on a day, and at the noon he was on the panel in Agriculture Empowered by Supercomputing in Denver. So I'm really, really honored to have you, Manish, and all the other speakers. Thank you.
Let's get started. So I wanted to start with a little bit of a disclaimer that this may not be the most technical talk, but let me give you some context. Until a few months back, I was as part of the U.S. Federal government, as part of the National Science Foundation there, and working in an office which over the 5.5 years that I was at the office, invested little shy of $2 billion on cyber infrastructure. Right? And while this is really impactful, great cyber infrastructure that's being run by many of the folks that are here in the room today, I also realized that there's a huge gap, and there was a gap in those who could actually benefit from that cyber infrastructure, right? And so this is something that I'm becoming increasingly passionate about, is how do we actually democratize access to the cyber infrastructure? How can we make sure that given all these resources out there, everybody can benefit from them, can use them not only to contribute to the research ecosystem, but also benefit from a social perspective, right? Impact their lives. So in this talk, I'm going to do two things. I'm going to initially just explore some of the insights I've received, and then talk about one project that was very recently funded that's being led by Ilkay, who's also in the room here today, that's trying to address some of these challenges in democratizing access to data. Again, it's one of many projects that are trying to do that, but I'll just talk a little bit about that. So I think this is obvious to everybody in the room, but clearly data, computation, cyber infrastructure more broadly is having a tremendous impact on science, on society. It's become a key enabler of innovation, of discoveries, right? And here are some pictures from the last few years. On top is a really impressive effort led by Romy Amaro. That picture is actually taken from the New York Times, right? There was a whole panel in the New York Times, and what it's trying to do is to model the COVID-2 virus in the respiratory aerosol. So when you sneeze, what happens? And this was very important a few years back. Some of you might remember the pandemic, right? So they used a whole bunch of computation, data, resources, varied set of resources as part of this workflow to come up with this understanding of what happens, right? And it was tremendously insightful in our understanding this virus and developing not only just ways to be able to address it and prevent its propagation, right? But it was just enabled by computation. And this is another very famous picture. This was the imaging of the event horizon of a black hole. This is the second one of the black hole that's within close to within our galaxy, right? But there was an earlier one in 2018, right? And then, more importantly, right, there are a lot of aspects, right? Whether it's reacting to urgent events, whether it's reacting to things that impact citizens, and having access to data really allows you to do that. And this is getting only more important with the growth of the increasing role of AI in all of this, right? And you know that AI is driven by computing and data, and as we increasingly use AI, having access to that is becoming very, very important. And this is just sort of highlighting this point. Go back to the same image I showed. There was a recent study that applied machine learning techniques to be able to come up with a more accurate, better image of the black hole, right? And there are many such studies. So with that backdrop, been trying to understand, right, how can everybody benefit from this infrastructure that we've all invested in? How can we make sure that everybody can get access to it, can contribute to the research ecosystem, can benefit from the research that's being done, the data that's being created, and it's well studied and documented that having a more diverse set of researchers involved in research leads to better research, right? And there are many other benefits of doing that, right? And there were some studies. There was a very interesting report out there, the Missing Millions report. Thank you. This helps, right? So there was a very interesting report, the Missing Millions report that came out, which really got into some depth about what does it take to make sure that everybody can benefit from all these resources, incorporated into the research. And they highlighted really three big barriers. One is knowledge, and that's really the awareness about the resources that are out there, how to use them, which is the right resource for me, how do I get access to them. There are often technical barriers in terms of, do I have the infrastructure, local infrastructure, that can give me access to that data, right, or to that cyber infrastructure. And then there are a bunch of social barriers, right? There has to be an understanding within the organization that having access to infrastructure is important research, so they can create the incentive structures, the support mechanisms, and often those are lacking in many, many institutions. And there are clearly a lot of trade-offs as one tries to build infrastructure, a lot of trade-offs that have to be optimized to meet the broadest set of resources. But overall, having access to a diverse infrastructure can lead to better research quality. It can lead to, especially in AI, better models that are fairer, that are more representative, right? So there are many benefits to broadening access to this research. If I sort of drill down on data itself, right, there are a few barriers that we are trying to address, right? One is awareness, and this is often something that you see a lot. Most researchers don't understand that why is data important? Why do I need access to data, right? What is the data that's relevant to me? What can help me in my research or tasks that I'm doing, or just manage, my everyday, my life, daily life, right? How can I use the data? Where do I find this data? So there's a lot of awareness issues that are there. There's the ability, right? Even if I know there's data, how do I have the skills that I need to be able to access the data, use the data? Where do I go for help? There is access, right? Once I know and I can use the data, how do I get access to data? That often requires a lot of local resources to be able to get the data, right? I still remember I used to be, before about maybe almost a decade back, I was running the infrastructure for the largest ocean observatory in the U.S., probably in the world, right? We had over 800 sensors deployed globally, real-time streaming data from the ocean floor. We had cameras, hydrophones, right? And whenever there was some interesting phenomena, right, there was a volcanic activity or seismic activity, everybody was continuously downloading data, right? While there were sometimes so many of the larger institutions would get data instantaneously, right, because we'd stream this data live. But then there'd be others that would send us an email or give us a call and say, I'm going to ship you a disk. Can you please load up the data and send it to me, right? And there's this, so it just immediately puts this gap between who can use this data effectively, who can benefit from this data in their research or in any other way, right, and those who cannot, right? So even though there's a lot of data, there are often a lot of access barriers. And then I think there are these association barriers because, often you want to be part of a community, right? You want to understand who else is using, what are the other data sets, what are the other pieces going on, right? So how do I become part of a community where I can benefit not only from the data and infrastructure, but from the shared knowledge that's there around that, right? Often you think about an instrument and you have the researchers or students gathering around it, right? Can we think of an infrastructure that way, right? And so part of the projects that we're looking at is seeing how can you really address some of these barriers and move from what we always highlight as open and equal, right, to something that's truly democratized and equitable, right? So often open and equal doesn't mean that everybody can benefit it. For example, the ocean data we created was open, right? But it was not equitable. It was not democratized. Right? So how do we get from open and equal to democratized? And this is not just, project. This is something that's getting addressed a lot across at least the U.S. federal government. And here are just some of the efforts that are there that are trying to address this in different ways. One effort that's getting a lot of attention recently is the National AI Research Resource, which is trying to do this to democratize access to resources for AI, understanding that AI is probably one of the most transformative technologies of our time. It also depends on a lot of computing and data, right? And there's a huge gap between the large organizations who have the resources to train the large models and a lot of other institutions which don't have them. So how do you create a national infrastructure in the U.S. that can democratize access to AI resources, right? And that's going on. In fact, just a few weeks back, NSF launched, along with the other federal agencies, right, as a U.S. federal all-of-government kind of a pilot effort for the research resource. And this is another thing that sort of came out in 2022, which is a memo also highlighting the need for open access to public results from publicly or federally funded research that includes data, and also here again emphasize the equity aspect of this dimension, right? So I talked about the NAIA. This just goes into say, but let me switch now and talk about the NDP. As I said, I'll talk about one project that's addressing some of these issues. This is a project that was funded and just maybe 3 or 4 months, 5 months old at this point, right? And it's really trying to address this gap, right? How do we create services for equitable access to open data, right? It's envisioned as this federal ecosystem that provides the core services, right, to be able to promote the access of data and the use of data broadly. It's driven by 3 use cases, and I'll talk a little more about it. But really, it's not trying to reinvent the wheel, right? It's trying to say, given the pieces we already have, we have infrastructure, we have services, we have data sets, right? How do we put them together in a way that can really broaden access and address some of the barriers that I talked about in the previous slide, right? And this is part of a broader effort that NSF funded called the National Discovery Cloud for Climate. Okay? So let me talk about, what are the basic pieces that this effort is trying to do from an equitable open access, right? The first thing it's trying to do is to understand what are the core services, right, that I would need to be able to broaden access to it. So if I were building a data infrastructure, what are the pieces? What are the basic abstractions and basic services that this infrastructure should provide so that everybody can benefit from this in an equitable way, right? Understanding what the use cases are, understanding what the infrastructure and what researchers may want to do with it. The second piece of this is then once I have this, right, then how do I build these services leveraging a lot of the pieces that already exist? Again, this is not really trying to reinvent the wheel. It's saying, how do I present services, infrastructure that's already there in a way that's more effective, more equitable from a usage perspective, right? So how do I build those different data structure? And then, how do I then create the policies and the governance structures on top of this so that I'm allowing the equitable use, but also the responsible use of this infrastructure and data, right? And especially as you go on, as I'm trying to do in Utah, go on to the tribal communities, a lot of these things become very, very important before a lot of these users, researchers, or practitioners trust you with their data or trust using the data that you provide. We do have a reference architecture, and again, it's trying to create the core capabilities and link it to existing resources, right? And then I'm not going to go through that, but let me walk through some of the big pieces here, right? The first piece out here is getting data, right? And there is, again, a lot of data sources, whether you look at the sensors, observatories, instruments, repositories that have already been funded, right? A lot of this data exists. It's amazing data, right? If you try to use it collectively. So how do you start from there, right? And provide a mechanism to allow users to acquire that data, right, in a meaningful way. And these are data hosted in different places, right? They're hosted in cloud, different repositories that's being streamed. So how do you be able to create a more uniform way to attach to these data sources and bring them to the user? Once you do that, how do you create mechanisms, support infrastructure for users to be able to find and discover that data set, right? Whether it's through catalogs, whether it's through discovery services, whether it's through search engines, or maybe recommendation systems, right? And there's a lot of technology that already exists where you can recommend, say, this is a data set that you might be interested in, right? So how can we build those services? Once you have that, how do you provide access to this data? And downloading the data to your local resources should not be the only modality, right? There should be other ways you can access the data, right? Whether it's leveraging existing infrastructure, right? Why should the typical modality, again, I'm going back to the time for the OOI, or the Ocean Observatory that I used to run. The only way you could access the data is to download the NetCDF files onto your own directory. And if you're using natural resources, then you upload the data again and run your workflow there, right? So can I shortcut that in some way, right? How do I do? Why can I move my computation to the data rather than downloading the data set, right? Can I do something more intelligent through caching, through prefetching, right? All these technologies, mechanisms exist. How do I bring them together so that the user can access the data without, having to download or having local resources, right? They can use the infrastructure to do that. How do you process the data using meaningful services, resource workflows, capabilities that already exist, right? And access them in a simple way, right? And then based on that, how do I then share and curate and archive the results that I'm getting, right? So the NDP is National Data Platform is trying to create services that can sort of bridge this entire pipeline. And the goal, again, is to enable researchers to be more effective with their research. And as I said, there were 3 different use cases that we were driving with. As initial thing, one was on early earthquake warning, and I'll talk a little more about this. Wildfire management. Again, this is looking at streaming data, right, and data coming in from GPS sensors and satellites and seismometers. How do I put it together in a meaningful way so I can do in a near real-time way to be able to do early earthquake warning? This is looking at large data. How do I do wildfire management using very large models, data sets, and be able to better predict how to more optimally deploy and use resources? And this is using open knowledge networks to be able to understand and address issues around food security. So I'll just dig deeper in a couple of use cases. So this is the early warning use case. And again, we're just getting started. And here we're using GPS data from the GNSS, right? And what we're doing is 2 things here, right? And this is in collaboration with the Earthscope Consortium. On one side, we are getting real-time data streaming in, right? We take these large data streams and we are able to do 2 things. We'll be able to allow users to run analytics on that live streams using in-situ resources, right? But we also archive those streams, right, and use them to train models, right? And so basically what happens here is that whenever we see some activity that's interesting, we then trigger this fake quake simulation. And what's happening there is that often you don't have enough data, and to be able to retrain your model, you need to be able to generate synthetic data that is meaningful from a science perspective. And this fake quake simulations allow you to do that, right? And so this is sort of a continuous cycle. You're always monitoring real-time data. You're creating archives out of that, but you're also using it when needed and the resources behind it to be able to run these large simulations so I can make sure I have enough data to retrain my model when I need to do that. Okay? And I have a demo for this that I can show you if we have time. This is the second one, and this is in partnership with NOAA and NASA, right? And this is looking at satellite data. It's streaming satellite data coming from the GOES, right? The Global Geostationary Operational Environment satellite data, right? It's coming in. It comes in at pretty high frequency, right? You'll be able to intercept that data that's coming in, and a lot of this is hosted on the cloud, right? And once again, we are able to run analytics on the cloud close to the data, right? And allow researchers to subscribe to features in the data. For example, if they're interested in certain behavior in certain regions of data, they get notified when that happens. And this is really interesting to NASA because typically the modality is they have to download the entire data, which is expensive from a time and resource perspective, but also a cost perspective, right? They're often hit with egress costs out here. So by being able to do a lot of analytics and only subscribe to data that's interesting, that allows them to be able to use this data more effectively, right? Again, these are just initial use cases. The idea here as we grow on is to understand, what these workflows are, but how are they meaningful from a broader community, right? Not just NASA and EarthScope, but how can the broader community benefit from these things? How am I doing for time, Nicholas?
Can you say a word or two about the data adapter?
I'm sorry, go ahead.
The data adapter, the scraper, can you say a little bit more about it?
Oh, which data, sorry?
The data adapter, the scraper.
Oh, right. So this is the way, since we have a heterogeneous set of resources that we want to get data from, right? The data adapter is interfacing with the native format that's that the GOES data is using, right? The NEA, and then presents it in a way that we can integrate it with the rest of the infrastructure, right? So it's a way of being able to get the data, extract the metadata, register the metadata with the metadata service so it can be discovered, but also be able to access the data within this data staging service that we are creating.
But it's not in AWS. It's not in AWS.
Oh, this is all running on AWS or wherever close to where the data is. Okay, the idea is not to download the data. So how am I doing for time? Okay, the reason is that I'm hoping to maybe see if I can show you a demo. Okay, let me show that to you. And this is when I say a prayer. So what's happening here? Right. So again, this is live. So we are getting from the we're getting 1 hertz. So every second we're getting GPS data. Right. This data is being streamed. All this is running on Amazon. Right. So this data is being streamed, and this is streaming data adapter. Right. You're doing 2 things here. The first, and you'll see both of them. The first thing we're doing is to create a repository. So we're taking windows of this data and archiving it in a way using this infrastructure called Open Science Data Federation and Pelican. Right. This is a large project, which what it does is creates a federation of data that's closely connected with the Open Science Grid, so that any of your computational workflows running here can access the data without you having to upload the data to those resources, right? They immediately mount or directly mount that data close to where your jobs are going to run and be able to stage the data there and access it, right? So from a user's perspective, it makes it much simpler. The second thing it does is being able to publish the data using a Kafka broker, which you can subscribe to and have runtime visualizations of this data. And what we are looking at here is to see the movement, right, in millimeters along the X, Y, and Z coordinates that the GPS data that the instrument is experiencing, right? And so the data adapter maps that data into a catalog. The user can discover the stream, right, and be able to subscribe to it, but also run analytics. And here we'll run a simple SVM analytics where we are trying to see anomalies. At this point, this is not very scientifically meaningful, but just shows the fact that you can do this without downloading the data. The larger goal here is to do early earthquake warning, and that's a large project the Earthscope Consortium is working on. And so let me scroll down here. And again, this is an early demo, so there's a lot of code that can be abstracted out using libraries, and we haven't done that yet. But what you're seeing out here is going to the, is basically going to the catalog and finding this server, right? So we are interested in a certain location, and we find the GPS server that's there that we want to connect to and get the data, right? And so we have registered it in a metadata service, and we can query it directly out here, right? Moving, so the next thing we do is to find where is that sensor geographically, right? And this is, again, a live sensor that we are going to, and this is in California where the sensor is, right? So we plot the coordinates, and we say, okay, this is the locational sensor that I was interested in. This is where it is, and I can use this to find out what's nearby, what are the other data that I can bring in towards this stop. The next thing we're doing out here is to run a simple analytics on the data. And this is doing an anomaly detection. So basically, what we're seeing is the movement along these three directions of this seismic, and it's looking over a window of data, and it basically tells you how big a window it is. And so it's basically running out here, right? It's running over 50,000 observations, and it's a running window. So right now, it's trying to see what are the anomalies out here. And there are two messages out here. This is running on where the data is being archived, right? So it's not having to stream the data to the user and then run it. So you can upload your analytics to this platform. And the second thing is that you're dealing with this, doing some live analytics on the data. And the next thing that this notebook is doing is plotting the data in real time, right? So this is, again, 1 Hz streaming data that's coming out of the satellite, and you can basically look at what the displacement is on the three dimensions out here. Okay, and this is, again, it's early days. I said this is a 5-month-old project, but it tells you an idea of what you can do with data from a user's perspective. Running this out from your Jupyter notebook, right? You're able to access data that's there. These satellites are being run by NOAA, right? So it's NOAA data coming out of the National Oceanic and Atmospheric Agency, right? And they're basically get access to it. I'll go to the second one quickly, but this is, again, early days, and this is sort of something that we again trying to see how do we connect to existing infrastructure, right? And one of the infrastructure that I hope Pete is going to talk about, and I hope I'm not stealing his thunder here, but this is a amazing infrastructure that allows you to deploy analytics on sensor platforms and program those sensor platforms. So it's sort of a software-defined kind of a sensor platform. So we are connecting to it. Again, we have an adapter that pulls it out, registers it into a metadata catalog. And now, again, we're doing two things out here. One is creating an archive of this data so that it can be integrated into Open Science Grid workflows, right? So now people can access this data as part of their workflows. But the second thing we're doing is streaming this data so that you can subscribe to it and run real-time analytics. So what we're going to do out here in this notebook is to be able to allow users to connect to this and visualize, and we're looking I think it's wind data that we're looking at, right? But at the same time, we're running a simple statistical modeling, a linear regression on the archive data, and we plot it along with the observed data, right? And again, it may not be scientifically meaningful, but at least it's a proof of concept at this point. All right, I'm done. And so, again, here there's a lot of code because we're doing the same step. We're discovering the different sensors that are there on that platform, and then I'm going to get to the end, and there you are. Right, there are two things here that you're seeing. One is the data that's streaming in right here, right, and this is the linear regression that's running using, again, this is on Amazon, right, on the archive data, and it's trying to predict that, right. And again, the message here is that you can remove some of the barriers to accessing data, providing the right abstraction services, right. I'm out of time, so I was going to go back to the slide, but maybe I'll just go back to my slide and open it up for questions.